silliness. Let's do number 15 of worksheet 4. And then we'll do however many of these we need, then we'll do some worksheet 5, and then you'll have time to work on your own. All right, number 15, I see a secant squared and a tangent, so I'm thinking it's that Pythagorean identity. I know sine squared plus cosine squared is 1, so if I want tangent to show up, I'll divide everybody by cosine squared. So tangent squared plus 1 equals secant squared. Now, how do I want to use that, though? Do I want to replace secant squared, or do I want to replace tangent? Secant squared, because it's squared. Tangent isn't even squared. So in place of secant squared, I'm going to put tangent squared plus 1. Everything else stays the same. And then I can shuffle things around, move everything to one side, collect like terms. So tangent squared x minus 2 tangent x minus 3 equals 0. Let's factor this. Tan x and tan x to get tangent squared. 3 times 1 will give me 3, and 3 minus 1 will give me 2, if I do the signs the right way. 3 and 1 with a minus 3 and a plus 1. So I set them both equal to 0. This is the step that you almost always skip in easy factoring, and a lot of you skip it even now, which is fine. Tangent of x equals negative 1. Tangent of x equals 3. So we've reached the point where we always get in that factoring does for us. It takes a really impossible problem and turns it into 2 problems, but 2 easier problems. And I like this one because this side is a unit circle value, and this side is not a unit circle value. So this kind of question could be on the calculator part. Well, it'd have to be on the calculator part of the test to solve this piece of it. But I would still want an exact answer. You'll see this tomorrow on the warm-ups. It says, use exact values when possible. Well, I can give an exact value for this one because tangent is negative 1 at negative pi over 4 plus pi k if I want to get them all. Tan x equals 3, that I can't get an exact value for. That I'll have to use the calculator. Inverse tangent 3, 1.249. And then the tangent rule is just plus pi k gets all of them. So 15 is a good one because trig, identity, substitution stuff, factoring, one with the unit circle and one with the calculator. So that covered a lot of stuff on that one. That's a good question. Number 16 on worksheet 4. Let's get cosecant by itself first. So that would be 2 over square root of 3. Add the 2, divide by square root of 3. And then I could fix it, but I don't really want to fix it yet because what I really need to do is change the cosecant into sine. And what's the cost, or what else do I need to do if I'm going to change cosecant to sine? I'm going to flip the other side because cosecant and sine are flips. So it's like I'm flipping both sides of the equation. So sine equals root 3 over 2. That would be in the first and second quadrant. Root 3 over 2 is the long side, so this means the y side is the long side, so that ends up being the steep angle. So that's pi over 3 for the first quadrant answer. For the second quadrant answer, 2 pi over 3. Also, the sign rule for calculators is pi minus the first answer gets you the second answer. So that's still true here. If my first answer is pi over 3, pi minus pi over 3 is 2 pi over 3. So you don't need that, but it helps maybe if you get stuck. And then plus 2 pi k, plus 2 pi k. And so there's my two answers, or two sets of answers, I should say, for number 16.